All right, so here's your lesson for Unit 7, Day 2. We're going to talk about graphing exponential functions. And again, we just like before, when we say graphing, we're trying to find a fast way of doing it. We're looking for patterns. We're looking for ways to do it quickly within a few seconds. When I say a few seconds, like 15, 20, 30 seconds. We don't want to make a table every time. This table is just to show you what the pattern is and how to look for that. So my learning target, I can sketch exponential growth and decay functions, y equals ax plus b, that's the form they're in, and identify the domain, the range, this idea of asymptote. I'm not sure if you've heard of that before, but we're going to explain that, and then intercepts. So we'll talk about x and y intercepts and which ones it has and which ones it doesn't have. So first off, I've got, and there's not really a technical parent function. This is probably the closest thing to a parent function that exponentials have. There's no like specific number there to use to make it a parent function, but they all have the same shape. So we're going to be able to look at the shape, and from that you can get your sketch down. So first off, I've got some numbers here to fill in. And keep in mind that when you have a negative exponent, remember that's like flipping it over. So if I plugged in 2 to the negative third, that's actually over 1 right now. I need to flip that over and do 1 over 2 to the positive third. So that's where this is coming from. 2 to the third is 1/8. Okay. Same thing with negative 2. I have 2 to the negative second power. That's actually 1 over 2 to the positive second power, which is 1/4. And then we get 1/2. Now anything to the 0 power, anything to the 0 power is 1. And if you kind of look at the pattern here, look 1/8 to 1/4, that's double. So double it, double it, double it. That pattern is going to keep right on going. So if I have 2 to the first, that's 2, 2 to the second is 4, 2 to the third is 8. So as I go up the steps, I'm doubling, and that is the multiplier here. Your initial value, there's no number out front, was 1, and that's what I got. When I plugged in 0, I got 1. Okay? So if I graph that guy, and again, this one is growth, because the multiplier is more than 1. It's going up. As x increases, y is also increasing, so that's growth. So this would be displaying growth. Now 1/8, kind of tough to draw that, but I'm going to go over 3 and go up just a little bit. So I'm just barely above the x-axis. Negative 2 would be 1/4. So a little higher, actually twice as high. Go left 1, I'm up 1/2. At 0, I'm at 1. So you see how it's kind of building. It's not growing very fast, but it's doubling. When I get to 1, I'm at 2. When I get to 2, I'm at 4. I'm sorry, 1, 2, 3, 4. I missed it there. That bothers me, so I'll do this. And then when I get to 3, I'm at 8, so I'm off the chart. So you kind of see this shape here. Now if I go to the left, starting here, it's going to go like this, and it's going to shoot up pretty fast. Now, it is never straight up and down. That can't happen. If it's straight up and down, that means it would fail the vertical line test, and it wouldn't be a function. So it never, ever is perfectly up and down, but it's going up pretty fast. Now, if I go to the left, though, I'm going to cut that. So right now, I'm at 1/8. I would double going to the right, so I'm going to cut it in half going to the left. Half of an 1/8 is a 16th. Half of that's a 32nd. Can I ever take half of something and get 0? Can't happen. So half of something is always something. So this line, it approaches but never ever touches the x-axis. So we talk about the intercepts. The x-intercept, it has none. These don't have x-intercepts because you can't ever be 0. You can't have something to a power and get 0 for an answer, because if you have anything to a power, you're going to get something. Okay. Now, that idea of getting really close to something without ever touching it, that's what an asymptote is. Okay, so it's an imaginary line that a function approaches but never touches. Okay, so I'm going to get this function gets really close to it, but it never touches the x-axis. So on the x-axis, there's this imaginary line dotted at y equals 0 that it never touches. That's my asymptote. Okay, so it's a horizontal line, so it's a y equals, and it's at 0, so it never touches it. It's at y equals 0. That's my asymptote. Now this one here, this other function, so second function is 1/2. This is a decay function because the multiplier is 1/2. So every time I go up, I'm going to be cutting stuff in half. So here, when I had 1/2 to the negative third, remember that negative power means flip it. So flip this over, that'd be 2 on top to the positive third. Okay, so this is going to be 8. And if you have trouble believing me on that, which I think you believe me, but if I took 1 divided by 2 to the negative third power, I get 8. So it is a whole number. Then same thing, if I have negative 2, flip it over. 2 squared is 4, which makes sense. I'm cutting it in half every time. So half of 4 is 2. Well, 2 to the fourth is 2. Again, anything to the 0 power. 1/2 to the 0 power is going to be 1. Again, half, half, half. 1/2 to the first is 1/2. 1/2 squared would be 1 squared over 2 squared, or 1/4, and 1/8. I just keep cutting in half. So here, whenever I plugged in negative 3, I was off the chart at 8. So way up there somewhere. When I plugged in negative 2, I was at 4. When I plugged in negative 1, I was at 2. When I plugged in 0, I was at 1. When I plugged in 1, I was at 1/2, 1/4, and 1/8. So you kind of see what happens here. If it's growth, from left to right, it's going up. If it's decay, from left to right, it's decreasing. Okay, so this guy, it would keep going up to the left. It's going to go off the chart. But as I come to the right, again, I'm taking half of the previous amount as I go to the right. So if I continue to take half of something, I'll always have something left over. It never actually touches the x-axis. Okay? So these answers over here apply to both. So this one has an asymptote of y equals 0. This one has an asymptote of y equals 0. The x-intercept is none. It never touches the x-axis. How about the y-intercept for both of those? Well, they both cross that 1, which if you look, that's the initial value. These both have a 1 out front, so that's your initial value too. So remember, y-intercept is a fancy name for initial value. So the y-intercept would be 0, 1. When you plug in 0, you get 1, 0, 1. Now for both of these, the range, all right, so let's do domain first. The first one goes right forever, goes left forever. I can plug anything in I want for x. I can take 2 to any power I want. So this is going to be negative infinity to infinity. The range, if you look, the range up and down, I never have any negative values. Okay? Because both these bases are positive. If I take a positive times itself any number of times, I get a positive. I'll never get a negative. So it's always going to be above 0. Now, it never will equal 0. So don't do a brace, do a parenthesis or a bracket. Don't do a parenthesis because 0 is not included, and then off to infinity. Okay, that took a lot longer than I thought it would. It took almost 9 minutes. So let's keep going here. This guy here is a little different. It has a number out front. So this guy up here had no number out front. This one has a number out front. That doesn't change a ton. Now if I start plugging numbers in here, again, that 3, that's your initial value. So when I plug in 0, I'll get 3. Well, if I plug in 0, I get 2 to the first power, which is 1. 1 times 3 is 3. So I got my initial value. Growth. So every step I go to the right, it's going to double. So this one here, I've got 3 times 2 to the first. Now be careful on this. 3 times 2 to the first is very different than 3 times 2 to the first. Actually, this one's not. Oh, the other ones it will be. Let's do the second power. Okay, so this one is 6 no matter what. I didn't think ahead on that one. Now let's do 3 times 2 squared versus 3 times 2 squared. Those are very different numbers. This is the one you want. You're doing the exponent first, then multiplying. So here I've got 2 squared is 4. 4 times 3 is 12. Notice I'm doubling, double, double, double. If I'm going back this way, instead of doubling, I'm going to be cutting it in half. Well, I got 3 times 1 over 2 to the first, because 2 to the negative first means flip it over. That'd be 3 halves. Well, half of 3 is 3 halves. Half of that would be 3/4. Okay, so I go to plot these, negative 2, 3/4, negative 1, 3 halves, and then 1, 6 would be right here. It's kind of the same thing, except its initial value is 3, and then it's doubling from there. As I go to the right, it's going to go up really fast, never be straight up and down. But going to the left, it never is going to touch. If I going to the left, I'm taking half of my previous value. So 3 divided by 2 is 3 halves, divided by 2 is 3/4. It's never going to get to 0. It's going to go that way. So here my domain goes left and right forever. So negative infinity to infinity. The range, 0, but not including 0 to infinity. Intercepts, I'm just going to put down y. I'm not even going to put down x-intercept. It doesn't have one. So y-intercept would be 0, 3, the initial value. And the asymptote, again, is y equals 0. Okay? So kind of speed things up here. Let's go a little faster. This video is getting long, and I want you to be able to go quickly. Not using a table here. So let's just go straight up. My initial value is 4. That's your y-intercept. Okay. This guy, as I go to the right, I'm going to take 60% of that. So I'm going to take 60% of 4. So 4 times 0.6 would be 2.4. So I'm going to go roughly 2.4. So over 1, about 2.4, a little bit less than 2.5. If I go one more, I'm going to take 60% of that. So I'm over here about 1.4, somewhere in there. You kind of start seeing a pattern here. Again, if I keep taking 60% of something, I get something. So even though this is going to be going down, it never equals 0. So there's that asymptote there. The asymptote is y equals 0. This will keep going to the left like that. So we have the few points in the middle are the ones we need to be exact on. Other than that, it's just a sketch. Okay, it's going to go down to the right, never get to 0. It's going to go up to the left. This one's decay, so it's going down. If it's growth, it's going to be going up to the right. Okay, so it kind of looks like make an elbow shape. That's what I always call it, kind of an elbow shape. Okay, so maybe I'll just do a few of these since the video is getting long, and I want you to be able to start working on yours. So without a table, again, initial value is 0.5. So go to 0.5 and put a point. The multiplier is 3, so I'm going to triple that every time. So if I go over 1, I got to triple that. That'd be 1.5. If I triple 1.5, let's see, 1.5 times 3 is 4.5. So 1, 2, 3, 4.5. And I got my shape. I kind of got my idea here. So going to the right, I'm tripling. Going to the left, I'm taking a third. A third of something is always something, so I'll never get to 0. I'll never have a 0 y value. So it's going to be going along this line, and it's going to shoot up to the right like that. Domain, negative infinity to infinity. Range is from 0, but not including 0, because it never equals 0. Infinity. Intercepts, it says label important points of intercepts. So my intercepts, I got y equals 0.5. I'm sorry, 0, 0.5. And then the asymptote is going to be y equals 0 because it comes down towards 0 but never touches that invisible line y equals 0. Okay. Let's just pick. Oh, and if you want to quickly, maybe I'll say this too, if you want to quickly get some points, you can type this in. So I could put, let's do this, I'll do 4 divided by 5 to the x power. And if you want to make a table out of it, just to get some ideas, because you want to quickly see it, remember, go to table setup, second table setup, and you want to start at 0 and have a change of 1. And then go second table. So for this one, my and my y-intercept is 1, well, that's because there's a 1 out front here. It's not written, so it's assumed to be a 1. So if I switch these guys here, 0, 1, and then 1.8, 2.64. If I scroll up, negative 1, 1.25, we kind of start seeing the shape here. If I go up, negative 5, 1, 2, 3, 4, 5, I'm at almost 3. Kind of see the shape there, and it's going to make that elbow shape. It's going to be going up this way, coming down that way. But as I go to the right, I'm taking 4/5 of my previous amount. Well, 4/5 of anything is something, so it never gets to 0. So I'm going to have domain negative infinity to infinity, range 0 to infinity. The y-intercept on one, so I do have a different y-intercept, would be 0, 1, and then the asymptote is y equals 0, because it's going to hit that. So 16 minutes, I think it's long enough video. You do not have to finish this, so don't worry about finishing this. Just do your Math Excel. Again, my requirements are that you have to have at least 80% on it to be considered present. So I say at least 80% to be counted present. Okay, so do 100% of it. But if you're busy and you can only do 80% for now and then you want to finish it before 3 o'clock tomorrow, that's fine too. I should say 3 o'clock Friday is when it's due, so if you're wondering what time. So apologize for a long video, but hopefully that made sense, and your homework shouldn't take nearly as long since we explained it pretty in detail there.